Okay, we are going to be going over exponential functions, which is how is something that's changing at a quicker rate of time. And so, like what we're dealing with the coronavirus, how it's spreading quicker the farther up it goes. And so, when we're exploring these functions, they have certain key features. We're going to have an asymptote. We're going to know about the y-intercept and the max and the min over a range. And so if you'll go on to Desmos and you can type in this function right here, and we'll see what happens to that function over the time period that we're looking at. And so the way that looks is you'll have a graph that just slowly starts to grow really slowly, and then all of a sudden it starts picking up really crazily fast. This is an exponential graph. This line down here, where it doesn't cross, it's called an asymptote. And so this has a horizontal asymptote at y equals 0. The y-intercept is where it crosses the y-axis. If you can't tell it by looking at the graph, one of the other things you can do is you can plug in a 0 in for x. And so like down here, I could go, what is y when I have 2 to the 0 power? Well, that's going to be at 1. And the y-intercept is going to be 0, comma, some number, in this case, 1. And so if I ask you to analyze what is the max and what is the min when we look at these two ranges, you're just going to put in those two numbers. And so I'll do y equals 2 to the negative 3. And negative 3 in the exponent just means that I have flipped it over the x-axis. And so, or flipped it, had a reciprocal. So 1 over 2 to the third, which is 1/8. So anytime you have a negative exponent, it is going to move it to the denominator, and it's 1/8. Then if we have on y to the 5th, so this is going to be 2 to the 5th power. So 2 times itself 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's at 32. So in this case, 1/8, oops, let me try that again. 1/8 is my min, and my max is 32. Now, let's look at what happens if it was, instead of 2 to the x, it was 10 to the x. And again, I used Desmos, and I just put them on the same graph. What do you notice is the difference between these two? If you said that the 10 to the x is steeper, it increases at a higher rate. This is where they're talking about the avoiding contact, how it slows down the spread of the disease. It changes this rate factor that's being raised to the power. It changes how many people you affect each time. And this right here is an example of a steeper rate curve, which is with a 10 to the x. So our asymptote, the line it can't cross, is here. That did not change. It's still y equals 0. The y-intercept is going through the same spot. And again, you could test this out by putting a 0 in for x. Is at 0 to 1. But our min and max are going to be slightly different. So let's go ahead and look through those two numbers. So if I had y equals 10 to the negative 3, that means 1 over 10 cubed, which is 1 over 10 times 10 is 100, times 10 is 1,000. 1 over 1,000. Y to the times equals 10 to the 5th that's going to be 10 times itself 5 times, which when you're doing 10 to a power, the number of zeros represents the power. So that's 100,000. So this is our max. This is our min. So again, all you're doing is you're testing out the min and the max and seeing what those two numbers are. If it asks you what is the min and max on an interval, so you have to look at that interval it gives you, and those are the two numbers you're testing out. So the next thing is, this is the parent function. This is what the main basic function is going to be, where you have a times b to a power. If b is greater than 1, that's all the ones we have been dealing with. We've had it b being a 10, and we had a b being a 2. Those are all growth. We can also have decay. Decay is going to be like whenever you have radioactive decay, a population loss of something. So if you're looking at the loss of a species over time, that's also something that can be tracked through decay. And the decay, the b needs to be between 0 and 1. B is never negative. So the thing that we're raised into a power, we are not working with it being negative. And so let's look at one that is a decay. So you notice how the graph, instead of going up, is going down. And so the asymptote, only one, y equals 0. It's not changed right now. We will look at, as this week progresses, at one where those change. The y-intercept, if I plugged a 0 in for the x, so y times 1/2 to the 0 power, or y equals 1/2 to the 0 power, that's still going to be, in the 0 power is still 1, so 0, 1. When they are the parent function, which each of these are considered parent function, there are no transformations happening to them, then the y-intercept is always going to be 0, 1. The asymptote is always going to be y equals 0. Now, if we start adding things to it or moving this function around, that's when that